Welcome back, everybody, to another deep dive. This time, we're going to try to unravel the story of Paul Werbos. So you might not recognize his name right off the bat.
Okay.
But he is someone whose work is really woven into the fabric of modern AI.
Wow.
Imagine a world where machines can actually learn from their mistakes, getting better and better over time.
Yeah.
That's the world that Werbos helped create.
I see.
And that's what we're going to talk about today.
Cool.
But first, what I think is really intriguing is how this pioneer, someone so central to AI's evolution, isn't exactly a household name.
Right.
So are you ready to kind of uncover his story and look at what he did and why he's so important?
Yeah, I think what's really captivating about Werbos is how his journey really reflects this tension that we see in AI all the time. This race between revolutionary ideas and the technology that you actually need to bring them to life.
So it's the classic, science fiction trope of we invented this great thing, but it's going to be 50 years before we can actually do anything with it.
Exactly. Yeah.
So let's start at the beginning.
Go ahead.
What sparked Werbos's fascination with AI? I mean, was he building robots in his basement as a kid? What got him going on this?
Well, maybe not robots, but even as a child, he was really captivated by the idea of machines that could think.
Okay.
Really think like humans. So that really set the stage for his whole life's work, and his education played a really key role.
Yeah.
So he started at Harvard, immersed himself in mathematics, and then he went to the University of London, broadened his perspective a little bit, and started thinking about how math could tackle real-world problems.
Okay.
But then it was at MIT, the 70s, a total hotbed of AI research where things really took off.
MIT, of course.
Yeah.
The heart of innovation, as always.
Yeah.
So was everyone at MIT on board with this idea of thinking machines? Was that a thing? Was everyone cool with it?
No, it wasn't quite that simple. The AI community was actually pretty divided.
Really?
At the time. So some researchers were really into symbolic AI, which is all about logic and these really rigid rules.
Okay.
But Werbos, he was drawn to a different approach, something a lot more human-like, I guess. Mm-hmm. Neural networks.
Right.
Systems designed to mimic the actual structure of our brains.
So trying to replicate the complexity of the human brain with a machine.
Yeah.
That just seems, even for MIT, that seems incredibly ambitious, doesn't it?
It really is. And Werbos had this remarkable insight. He understood that to truly replicate the mind, you couldn't just rely on equations.
Right.
You needed to consider psychology, neurobiology, the actual intricacies of human thought.
That's fascinating.
Yeah. So it's a really multifaceted view, which ultimately led to his groundbreaking work. He wasn't just building a machine. He was trying to unlock the secrets of intelligence itself.
So this must have been what led to his famous breakthrough, backpropagation, right?
Exactly.
The algorithm that allows machines to kind of learn from their mistakes.
Yes, exactly. So in his 1974 PhD thesis, Werbos unveiled backpropagation.
Okay.
Think of it like this. Imagine you're learning a new sport, right?
Okay.
You practice, you make mistakes, you get feedback from, say, a coach. Then you adjust based on that feedback.
Okay.
That's essentially what backpropagation allows machines to do. Mm-hmm. Gives them a way to learn from those errors, from those mistakes.
Right.
They can continuously, refine their performance.
So before backpropagation, teaching a neural network was basically throwing it into a game with no practice and just hoping that it did okay.
Pretty much, yeah.
Right.
Before Werbos, it was a, monumental challenge to train these multi-layered neural networks. So his work was a total game changer, right? Really paving the way for the super sophisticated AI systems that we have today.
So I imagine this was a real eureka moment, he figures this out. This is amazing.
Yeah.
So how did the rest of the AI world react to this discovery? Were they immediately on board?
You'd think so, right?
Yeah.
But there was actually quite a bit of pushback.
Really?
Yeah. Some experts just saw neural networks as a dead end. And plus, the computing power that you really needed to unlock backpropagation, it just wasn't there yet.
Oh, okay.
So it was this classic case of a brilliant idea that was just way ahead of its time.
So Werbos was a visionary, but the world just wasn't quite ready for his vision yet.
Exactly.
So this reminds me of all those sci-fi movies where they invent something amazing, but it ends up locked away in a vault because, society's not ready for it yet.
Yeah, It's a great analogy. But just like those sci-fi inventions, Werbos' ideas eventually found their time to shine. Yep. And to really understand the scale of what he did, you need to kind of grasp another key concept, the universal approximation theorem.
Okay, that sounds intense. So what exactly is the universal approximation theorem?
Well, it states that a neural network, given enough complexity, can theoretically learn any function.
Any function, okay.
So any pattern, any relationship, a neural network, in theory, could crack the code.
Wow.
And this was like at the heart of Werbos' belief that we could actually create machines that were capable of human-like intelligence.
Okay.
He saw backpropagation as like the key to unlocking that potential.
So he wasn't content with just like the basics. He really wanted these machines to understand and learn it like almost on a human level.
Absolutely. And he saw the bigger picture. He didn't just theorize about it. He actively pushed for more complex networks, multi-layered networks. Mm-hmm. And these are now what we call deep networks. They're the foundation of the deep learning revolution that we're seeing now, right? Image recognition, language translation, self-driving cars, all these advancements rely on what Werbos championed back in the 70s.
It's crazy to think that so much of modern AI comes from this one person. It makes you wonder, like, what else was he working on? What else did he come up with?
Well, he wasn't just focused on the technical side of AI. He was also concerned about its impact on society.
Right.
Both the positive and the negative. He wanted to make sure that AI was a tool for good.
It's not enough to just, build powerful technology. We need to think about the ethical side of things too, right? What were some of his specific concerns? And did he offer any, solutions?
He did. And that's where our deep dive gets really interesting.
So we've established that Werbos wasn't just this brilliant scientist, but a real forward thinker, especially when it comes to AI and its impact.
Yeah.
So what kind of solutions did he propose? Did he think we should slam on the brakes, just stop all AI development?
No, actually, he had a more nuanced take. Werbos believed that AI could actually help us tackle some of our biggest challenges as humans.
Okay.
Particularly stuff like energy and sustainability.
Mm-hmm.
He got more as a tool to amplify human ingenuity.
Oh, interesting. So not replacing humans, but actually working with us.
Exactly, yeah. More like a partner.
Okay. So what were some of the specific areas that he really focused on?
Well, one that he was really fascinated by was energy efficiency.
Okay.
He believed that AI could revolutionize how we manage and consume energy, making systems smarter and more eco-friendly.
Okay, give me an example. How would that actually work in the real world?
Imagine a world with smart grids.
Yeah.
Right?
Okay.
Electricity networks powered by AI, constantly analyzing data, adjusting energy flow to meet demand, but minimizing waste.
Okay.
Predicting energy needs, identifying inefficiencies.
Wow.
Even integrating renewable energy sources seamlessly.
So it's AI is this super efficient conductor of the entire energy symphony, right? Making sure that nothing is wasted.
Exactly. Exactly.
That's amazing.
And Werbos saw this potential extending to renewables.
Okay.
Like wind and solar power, which, can be a little unpredictable.
Right.
AI could help us forecast weather patterns, optimize the placement of solar panels, wind turbines, even manage energy storage to, smooth out any fluctuations.
It's like AI working with nature almost to really help us tap into these clean energy sources.
Yeah.
So was this vision limited to just energy? Or were there other areas, global challenges, that he thought AI could help address?
Oh, definitely. He was super passionate about using AI for things like environmental monitoring.
Okay.
Conservation efforts.
Yeah.
Think of all the data we have from satellites, sensors.
Right.
AI can analyze that, track changes in ecosystems, detect pollution, even predict natural disasters.
So AI could be our eyes and ears almost on a global scale.
Yeah.
Constantly monitoring the health of the planet.
Exactly. Like giving the Earth a nervous system almost.
And AI is the CPU.
Yes, exactly.
Wow. So we could spot problems before they get too big.
Yeah.
That's incredible.
Identify patterns that, we as humans might miss.
Right.
And react faster.
What about climate change? Did Werbos see a role for AI there as well?
Oh, absolutely.
Okay.
Big time. He envisioned AI being used to model climate scenarios, analyze those carbon footprints, and develop strategies to both mitigate climate change, but also adapt to the changes that are already happening.
Okay.
So things like optimizing resource management, developing more sustainable agricultural practices,
Right.
even designing cities that can withstand extreme weather.
So it sounds like Werbos saw AI as this powerful tool, right? Not a magic solution, but something that could help us better understand these complex challenges and find better ways to address them.
Yeah, exactly. It's about working smarter, not harder.
But of course, we've talked about how he was also aware of the potential downsides, the dangers of AI. So did he have any, guidance on how to, mitigate those risks and make sure AI is used responsibly?
Oh, absolutely. In fact, he was one of the first people to really push for what we now call responsible AI.
Okay.
The idea that, we have to develop AI in a way that benefits humanity as a whole and aligns with our values.
Responsible AI, yeah. I like that. It implies that there's a sense of accountability, that we're thinking about the ethics.
Right.
So what are some of the key principles of responsible AI development? What did Werbos say we should focus on?
Well, one of the most important things he talked about was transparency.
Oh.
AI systems should be explainable, meaning we should be able to understand how they reach their decisions.
Right.
Especially in those, high-stakes situations like healthcare, finance, criminal justice.
Yeah, that makes sense. If we're going to trust AI to make decisions that could really impact people's lives, we need to know how it's making those decisions.
Exactly.
Imagine a judge just issuing a ruling with no explanation.
Right.
You wouldn't have a lot of faith in the legal system.
Yeah.
Right? So what else? What other principles did he champion?
Well, another crucial one was fairness.
Okay.
He was really worried about the potential for AI systems to perpetuate bias, even amplify it.
Right. I've heard about that. If you train an AI on biased data, it's going to make biased decisions even if the people who programmed it didn't intend for that to happen.
Exactly. It's like teaching a child using only old textbooks that are full of stereotypes.
Right.
They're going to learn the wrong lesson.
Exactly. Yeah, that's a great analogy.
So mitigating bias means being careful about the data we use, making sure it represents everyone. Rigorous testing is crucial too. Catch any potential bias before it's unleashed on the world.
So it's not just about the code, right?
Yeah.
It's about understanding social dynamics.
Right.
And incorporating ethical considerations into the whole process.
Yeah. It's like writing a novel. You have to be aware of the messages you're sending.
Yeah.
The impact your words can have.
And the impact that this technology can have.
Yeah.
So we need this more holistic view of AI. It can't just be the computer scientist.
Exactly. Bring in the social scientists, the ethicists, the legal experts.
Right. So it sounds like Werbos was calling for a more collaborative and thoughtful approach to AI.
Yeah.
But even with the best intentions, things can go wrong, right?
Right.
Did he ever talk about the role of government regulation?
He did. He actually felt pretty strongly that we need some government oversight.
Okay.
To ensure that AI is used safely and ethically.
Okay.
He thought we needed regulatory bodies to set some standards.
Yeah.
To monitor, how AI is being used and step in, if needed, to prevent harm.
So it's not about stifling innovation. It's about having some guardrails.
Yeah, like safety features on a powerful car.
Right.
Seatbelts, airbags, traffic laws.
Mm-hmm. Did he have any ideas about what those regulations might look like?
Yeah, he had a few ideas. For example, he thought AI systems that are used in really high-risk areas like healthcare, transportation, should have to undergo rigorous testing and be certified.
Okay.
Kind of like what we do with pharmaceuticals or airplanes.
Okay.
And he also suggested we have red teams, independent experts who try to break the AI systems.
Oh, I see.
Find any vulnerabilities before they cause any real-world harm.
Like ethical hackers.
Exactly.
Trying to penetrate your system to find the weaknesses before the bad guys do.
Yeah.
That's really interesting. So it sounds like Werbos was thinking ahead, anticipating the problems, and trying to come up with solutions proactively.
Yeah.
But he wasn't just focused on the technical and regulatory side, right?
Yeah.
He also believed that public education was important.
Oh, absolutely. He felt very strongly that people need to understand AI.
Okay.
How it works, its potential, the good and the bad, so they can participate in these discussions.
Right.
About its role in society.
Right.
Public awareness, engagement. That was crucial for him.
Like any big societal change, we need to talk about it.
Right.
Air our concerns, make sure everyone has a say.
Exactly. It's not just for the tech people and the politicians to decide.
Right, exactly. And that kind of brings us back to the question that Werbos posed, which I think is even more relevant today as AI gets more and more integrated into our lives.
Yeah.
What role do we want AI to play?
Yeah.
And what can we do to ensure that it's used for good?
Right. What steps can we take?
Yeah, that's a big question. One that I'm honestly still trying to wrap my head around.
Yeah.
This deep dive into Werbos' work has been so insightful. It's
Yeah.
given me a whole new appreciation for how complex AI is and how we really need to think carefully about what it all means. But before we finish up, I'm curious to learn more about Werbos himself, you know?
Yeah.
Like, what was it like for him to be this pioneer in such a groundbreaking field? Did he ever talk about his own experiences?
Yeah, he did. And there's this one story about a conference he attended back in the early 70s, shortly after he finished his PhD thesis on backpropagation.
Okay, you've really got me on the edge of my seat. What happened at this conference? Was it like a triumphant moment for Werbos, you know, finally getting recognition for this groundbreaking work?
Oh, not exactly.
Yeah.
Imagine this, right? It's the early 70s.
Okay.
Young Werbos, fresh out of MIT,
It's okay.
stands up in front of a room full of all these AI experts.
Yeah.
He's like, ready to unveil backpropagation, you know, share this revolutionary idea.
Yeah.
You'd expect, you know, thunderous applause, bunch of questions.
Yeah.
But he was met with mostly blank stares and skeptical murmurs.
Oh, no. That's got to be so disheartening.
It really is.
What was the issue? I mean, did they not see the potential?
Well, you got to remember, this was the early 70s.
Yeah.
The AI world was really all about symbolic AI back then.
Okay.
You know, systems built on logic and rules.
Yeah.
Neural networks, especially multi-layered ones, were seen as just too complex, too messy, and way too computationally demanding.
Oh, so it was just like the technology wasn't there yet to really take advantage of what he was putting forward?
Exactly. Yeah.
So it's like he was a jazz musician trying to explain like improvisation
Right.
to a classical orchestra. They were playing by different sets of rules.
Such a good analogy. Yeah.
And he's like, come in with this completely new thing.
Yeah, he's shaking things up. And, you know, as often happens with these really innovative ideas, there's pushback.
Sure.
Some researchers even told him flat out, you know, neural networks will never amount to anything.
Wow. Okay, so that must have been tough. I mean, to be told that what you're working on is just like not going to go anywhere.
Yeah.
It must have been really tempting to just give up.
Yeah, totally.
But Werbos really believed in his ideas, didn't he?
He did. He knew he was onto something big, even if other people couldn't see it yet. He once even compared himself to a salmon swimming upstream.
Wow. That's a good analogy. That takes a lot of like courage and determination.
It does, yeah, to go against the grain like that.
It's inspiring to see someone with that much conviction, even when like everyone's telling them they're wrong.
Yeah.
So it wasn't just like resistance from the AI community that he had to deal with, right? There were technological limitations too.
Oh, absolutely. We've talked about how backpropagation needs a lot of computing power.
Right.
To train those big multi-layered networks.
Yeah.
Well, the computers back in the 70s just weren't powerful.
So it's like having the blueprints for a supersonic jet,
right,
but not having engines that are powerful enough to get it off the ground.
Perfect analogy.
Yeah. So what did he do during this time? I mean, did he just like sit around and wait?
No. He was a tireless advocate.
Really?
Kept refining his algorithms, publishing papers, going to conferences, talking to anyone who'd listen.
Wow.
He even looked into using neural networks for things like political forecasting, just to show how versatile they could be.
So always pushing the boundaries, always trying to find new applications.
Yeah, very much so.
It's incredible that one person working like that kind of quietly laid the foundation for so much of what we see today in AI.
It's truly remarkable. Yeah. I mean, think about it. Every time you use a voice assistant,
Right.
see a picture tagged automatically online, or hear about a medical breakthrough, that's all thanks to Werbos.
It's almost like he planted this tiny seed
Yeah,
that grew into this huge forest of AI.
exactly.
And amidst all this progress, we can't forget Werbos was really concerned about the ethical side too, right?
Oh, totally. He believed that AI could solve these huge problems.
Right.
But he also warned against just blindly chasing progress without thinking about the consequences.
Yeah.
You know, he really pushed for transparency, fairness, accountability,
Right.
all things that are even more important today.
Absolutely. It's on all of us, you know, scientists, policymakers, business leaders, just regular people to make sure that AI is used for good.
Couldn't agree more. And Werbos You know, with his brilliance, his ethical thinking, and that determination, he's a great model for how we should approach all this.
This deep dive has been so eye-opening. It's amazing how the story of one person, often overlooked, can tell us so much about AI and the questions it raises.
It's been a pleasure exploring this with you.
Likewise.
And I hope everyone listening will be inspired by Werbos' story
Yeah, I hope so too.
to engage with these important questions.
Absolutely. And help shape the future of AI for the better. So to our listeners, thank you so much for joining us.
Yes, thank you.
This has been a fascinating journey. And until next time, keep exploring.
Yeah, keep asking those questions.
And keep thinking deeply.